So the goal for today is we are going to be able to use the periodic table to predict properties of elements. So the periodic table is organized so we can find elements with similar properties. How do we read the periodic table? Well, we look in horizontal rows called period. From left to right, we read these numbers. And actually, you can kind of see 1, 2, 3. And the vertical columns are called groups or sometimes called families. Vertical meaning you read them from top to bottom. One of these notable families is Group 1A called the alkali metals. Group 2A are called alkaline earth metals. 7A is another one of the more common ones. These are called halogens. And group 8A are called noble gases. And we'll talk about why this distinct name a little bit later. So another way we can approach the periodic table is by looking at it as a group of main elements. For the purposes of this class, you're going to be interested in these things called main group elements. This is 1A, 2A, 3B, 4B, 5B, 6B, 7B, 8B. We will sort of, especially for this unit on batteries, we'll slightly talk about transition elements, which is this block over here. But we will probably never meaningfully engage with these called the lanthanines and actinides. And they're in period 6 and 7. So for the most part, we're going to focus on the blue. So how do we categorize elements? So generally we have three categories. One category, which is, as you can see, the largest in the periodic table, are the metals. They are shiny. They are malleable, which means we can bend them and turn them into wires into our iPhones. They conduct heat and electricity. In the middle, we have this staircase. We call this a staircase called metalloids. And they have properties of metals and nonmetals. And you're like, Miss Mel, what are nonmetals? Well, nonmetals are in the green. They're poor conductors of heat and electricity, so you'll usually find them as insulators. We can use the periodic table also to predict states of matter, and it shows that if these are also metals, most elements are solid at room temperature. Few elements are liquid at room temperature. And several elements are gas at room temperature. And then I just wanted to point out that hydrogen's still hanging out there. One of the key ideas that you should be very masterful at by the end of this unit is that we can use the periodic table to identify patterns in the number of valence electrons. And we're going to abbreviate this phrase because we're going to use it so much as VE. As we talked about, we read the periodic table from left to right in periods. In period number 1, we have one shell. What do you mean by shell? We have this exact ring where here there is one electron. In period 2, there are noticeably two shells. For lithium, there's one and then two. For period 3, there is three. And period 4, there are 4 shells. And now we can actually start looking patterns across the period. So here we have one valence electron across all the group 1A elements. I'm actually circling them to identify them. So we notice that all these have one valence electron. Here there are 2 valence electrons. 1, 2. Here there are 1, 2, 3. Here there are 1, 2, 3, 4. And I think you're identifying a pattern that all these numbers correspond to the group number, which is why we call these main group elements. Miss Mo jumped the gun. This should be 7. And then this is actually 8. Where neon there's 1, 2, 3, 4, 5, 6, 7, 8. And same for argon. So helium also breaks the rule because it has 2 valence electrons. And so we see some misbehavior with hydrogen and helium in our periodic table. And they've been moved around many times over. So I wanted to take away the big idea from this lesson is that the periodic table is used to find patterns in the following properties: the state of matter, the physical properties, the atomic radius, the relative reactivity, the sticks, the types of compounds it makes. And that's what you should have taken from our build a table activity. Please keep asking questions and good luck on your next assignment.